Okay, today we're going to discuss something more intriguing and somewhat hypothetical. Something that's going to take quite a while to prove and potentially, I guess, will never get proven. But it's in regards to the mysterious idea known as dark energy. Or actually, to be more exact, it's in regards to what's known as the expansion of the universe. The idea that the universe is expanding, it's also accelerating its expansion, and it's been doing this for at least a few billion years. Something that has been confirmed many times, with one of the recent videos in the description describing this in more detail. But when it comes to this expansion of the universe, for many years now, the explanation was kind of, I guess, a little bit vague. It's known as dark energy. It's this something, possibly a particle, possibly some kind of a phenomenon, that's causing the universe to expand. But exactly what it is and exactly how it does so has always been kind of hypothetical and never really proven. I mean, some explanations involve some kind of a negative energy, which could be basically pushing everything away from everything else, with some other explanations just relying on the idea of cosmological constant. In other words, maybe it's just part of the universe itself. It's part of the formula. It's a constant. But in all of these cases, there is a bit of a problem. There have been additional observations that create additional problems for things like, for example, this being a constant. For example, modern observations discovered that the universe seems to actually change the acceleration rate with time. It's known as the Hubble tension, and a constant cannot possibly explain this. On top of this, if we ever try to measure this dark energy particle, or whatever it is, it's just not massive enough and not even dense enough to ever be discoverable right here on planet Earth. So there's just no experimental evidence we can use right now to try to discover what's causing all of this. Nevertheless, based on previous calculations and studies, we know that whatever it is, it seems to be the main component of the universe. Possibly up to 68% of everything, total energy in the entire universe, is this unusual dark energy. The effects producing acceleration. And though there are obviously quite a lot of explanations trying to tackle all of this, today we're going to discuss a somewhat intriguing one, and I guess it kind of involves bubbles, the universe bubbles, and it does make quite a lot of sense. And so, hello info person, this is Anton. Let's discuss this new proposition that was just released as a paper a few days ago, focusing on exactly what it tries to explain, how it does so, but more importantly, how it actually does a pretty good job at explaining quite a lot of mysterious phenomena, including inflation. And more importantly, in the next few years, we might even have evidence to see if this hypothesis has any merit. And so, what exactly is happening here? Well, first of all, we have to remember that there are so many different explanations for dark energy, and actually quite a lot of them do make sense to some extent. You can learn about some of them in the description, but for example, we have things like quintessence, some kind of a mysterious substance, that's also been proposed as a really good explanation for everything. But once again, because there's just not enough physical evidence yet, we don't really know which one is correct. They all kind of make sense from one angle or another, but without physically seeing something that proves them, we're not going to know for sure. But what makes this particular proposition, I guess, exciting is that it also involves the idea of multiverses, or technically parallel universes, with all of these universes basically being kind of like bubbles floating in this inter-universal space. And they don't just float around, they also seem to interact. And so the proposition here is that, well, maybe the reason the universe is actually expanding is because once in a while, our universe kind of absorbs some of these smaller universes that come in contact. And as it collides and absorbs these smaller universes, by absorbing them, it basically grows in size, increases in space, and thus appears to have expanded over time. And intriguingly, their model, in terms of mathematics and in terms of the actual physical explanation, does not actually violate anything and seems to make some sense. Here's how they represent this in their study. And so here, the blue universe, or our universe, grows in size as tiny baby universes represented in red collide with it. And I think it's pretty easy to imagine this if you look at these bubbles. So basically the larger bubble grows larger and larger as smaller bubbles join with it, expanding it over time. And so this idea of constantly merging universes mathematically explains the expansion of the universe pretty well. Moreover, their model seems to even fit the observational evidence slightly better than the standard cosmological model. Especially because they're able to show that over time, because of the changes in the way universes collide, we should also observe a kind of a change in the way the bubbles grow, which is basically their explanation for the mysterious Hubble tension. But here, because we still don't have enough observational evidence, we don't really know how accurate this is. As a matter of fact, one of the predictions for this particular model is that with future observations from telescopes like the Euclid telescope, the telescope that just began its operation and that you can learn more about in one of the videos in the description, can actually one day provide enough evidence to see if this model makes any sense. In other words, future observations might give this model a little bit more credibility. And so the collision of these bubble universes explains the acceleration of the universe. It also explains the Hubble attention, or why the acceleration changed over time, but it also seems to explain another really intriguing phenomenon that doesn't really have a good explanation. And here we have to start with reminding ourselves what the timeline of the universe looks like. This is what happened in the last 13.8 billion years. You can see that there is a Big Bang right there. Then there was a sudden expansion of the universe known as the inflation, and then the universe kind of expanded relatively constantly until it started to accelerate the expansion in the last 4 billion years. And so this part, the accelerated expansion, that's what their paper explains through increases in these bubble collisions that started to happen in the last 4 billion years. But it also explains this part, the inflation, and that's actually the intriguing part. Their mathematical analysis also explains what must have happened right after the Big Bang. And once again, it's something to do with these bubbles. And so according to their study, as soon as our universe was born after the Big Bang, it was possibly some kind of a tiny bubble. And that bubble might have joined another massive universe. A universe that might have existed much longer than ours, but because of that joining process, in our data, it appeared as suddenly everything expanded in size, with all of this happening almost suddenly. Now, according to the models today, we know that the inflation happened something like 10 to the power of minus 36 seconds after the Big Bang and lasted for just a fraction of a second. And during this time, the universe really just expanded suddenly for practically no reason. Now, one of the best explanations today involves what's known as the Higgs field, or kind of a collapse inside the universe. You can actually learn more about this in one of the recent videos on the false vacuum decay, once again somewhere in the description. But in a nutshell, the previous explanation was, I guess, a little bit difficult to prove once again. Here though, their bubble explanation kind of tackles a bit of everything. The interaction of these multiple or parallel universes individually explains some of the biggest mystery in modern cosmology. And so basically, according to this idea, first, our universe, right after it started as a tiny bubble, joined a much larger bubble, which resulted in inflation. Then, it stayed in this form for billions of years until other bubbles started to join in, expanding the main universe even larger. And with more and more interactions, and as the bubble grew larger, more and more started to join in, accelerating the expansion even more, which is kind of what we're observing overall. But even though the calculations here and the model itself does, I guess, make sense, it's really important to understand that there's zero evidence. Okay, maybe not entirely true. Let's actually briefly talk about one piece of evidence from some of the previous studies from a long time ago that has been suggested as a potential sign of one of these bubble universes. You can learn more about this in one of the videos in the description, but approximately 10 years ago, there was a somewhat controversial proposition that this spot right here, or actually technically this spot known as the cold spot, something that's visible inside the cosmic microwave background, might actually be some kind of a sign of another universe interacting with our own bubble, possibly through some kind of a quantum entanglement. But this might have happened a long time ago, probably even before the cosmic inflation, and so this was not a sign of bubbles joining, just bubbles interacting. And though the explanation itself was obviously very intriguing, possibly providing evidence for the parallel universes, a much better explanation was that it might have been some kind of a super void, or basically just empty space, lacking matter and lacking galaxies. Something we know that does exist out there, and something that I guess made a little bit more sense. And more importantly, if this was a parallel universe interacting with our own, the researchers behind this proposition expected a very similar sign on the opposite side. So basically here, if we have something in the north, we should be seeing something in the south. Yet, so far, nothing like this has been discovered. Pretty much all of the detailed observations of the CMB only showed cold spot on one side, not the other. And so because of the lack of confirmation and the lack of data, at the moment most cosmologists don't actually believe this to be correct. And so the only evidence we had for these parallel universes, even now, is kind of controversial, and unfortunately is barely accepted by anyone. So we don't really know if these parallel universes even exist. But nevertheless, their model does suggest that if they do exist and if they do interact with our own universe, our own bubble, it would definitely increase the volume in the way we see the expansion to happen over time. And it would also explain the inflation really well, not to mention the Hubble tension. And so in other words, it solves several cosmological mysteries all at once with one somewhat intriguing, somewhat simple proposition. But assuming they are correct, we should technically be able to somehow see signs of these collisions somewhere, especially because many of them would be happening in somewhat modern universe. And so unless the researchers behind the study find a way to propose something that we can actually look for in order to see these physical mergers, at least for now, it's just probably going to remain a really cool explanation, but maybe not the reality. And by the way, there are quite a lot of very similar, very cool explanations, some of which you can explore in videos in the description. But it is quite possible that we might get more data from various telescopes that could see something out there. Something that might show us that maybe multiverses and parallel universes are real and are merging. We just don't see anything right now. But once we have some updates or some additional propositions, or maybe actual physical evidence in regards to these bubbles, I'll definitely make sure to follow this up with the next video. Until then, check out some of the previous videos on similar topics in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.